Have you ever wondered what happens when someone makes a multi-billion-dollar investment and then it just sits there, barely being used? It sounds crazy, but it's a massive problem happening right now at the very heart of the AI revolution. Today, we're going to dive into that exact challenge and the brilliantly clever solution a few tech giants came up with to unlock millions in hidden revenue.
So, who's involved in this story? Well, we're talking about some real heavyweights. You've got NVIDIA, of course, the engine behind pretty much all of AI. Then there's Telenor, a global telecom giant, Supermicro, a leader in high-performance servers, and Nvidia, the company holding the software key that unlocks this whole thing. Together, they're taking on a huge inefficiency in our AI infrastructure.
Okay, first things first, let's set the stage a little. Telecom companies are in the middle of a massive building spree right now. But they're not just putting down more fiber optic cables for faster Netflix. Oh no, they are building the actual superhighways for the entire AI revolution.
What they're building is this thing called the Telco Cloud Continuum. It's a bit of a mouthful, but what it means is they're creating this distributed network of computing power. It stretches all the way from these massive data centers, that's the Telco Core Cloud way over on the right, all the way down to the far edge on the left, which is basically the cell tower your phone is talking to. It's a whole end-to-end system, and it is packed with high-end NVIDIA hardware.
So what's the big deal with this network? Well, for one, it's a completely distributed infrastructure. You've got serious computing power everywhere, not just in some far-off data center. It's also an AI-ready platform, built from the ground up to handle all the crazy AI applications coming our way. And, this is the big one, it represents a massive capital investment. We're talking billions of dollars being spent to win the AI race. But here's the twist. After spending all those billions to build this incredible AI highway, the telcos ran into a huge problem. It's like buying an entire fleet of Formula One race cars, only to find out that most of the time they're just parked, in the garage, doing nothing.
And this slide, wow, this really shows you the scale of the issue. On average, only about 25% of all this super expensive, super powerful GPU capacity is actually being used at any given time. That means a staggering 75% is just sitting there, completely idle. This is what the industry calls stranded capacity. And every single second it sits idle, it's just lost revenue.
So here's what that looks like in the real world. A user, let's say an AI developer, sends a job to a specific part of the network, cluster A. But cluster A is totally maxed out, 100% full. Now, at the exact same time, cluster B and cluster C have tons of free space. But does it matter? Nope. The user's job gets stuck in a queue or just blocked entirely. The business opportunity is gone, even though there was plenty of power available just a little ways down the road.
So why does this happen? I mean, it seems kind of nuts, right? Well, it boils down to a few things. First, AI demand is what they call bursty. It comes and goes in these totally unpredictable spikes. But the supply of GPUs is static. They're physically bolted into racks in specific places. And like we just saw, a job that's waiting in line is a missed sale. But the biggest reason for all this is that there's no central visibility. Nobody has a single screen they can look at to see all their GPU assets and who's busy and who's not.
So how in the world do you solve this? Well, the answer is, honestly, it's brilliant. It comes from a trick that telcos have been using for decades in a completely different part of their business. This is the real aha moment of the whole story.
The concept is called oversubscription. And you've actually experienced this yourself, probably every single day. Think about your home internet. Your provider might sell a 1 gigabit connection to you and your neighbors and everyone on your street. But they don't actually have enough total bandwidth for all of you to download at max speed at the exact same time. They're making a statistical bet that you won't. They've oversubscribed the network.
And this is the genius of the solution. They realized that the exact same principle they mastered for network bandwidth, they can now apply to GPU compute power. It's just a shift from oversubscribing Wi-Fi to oversubscribing the entire AI infrastructure. It's the same idea, just on a whole new level.
And what makes this possible is a piece of software from Nvidia called the Elastic Grid Service, or EGS for short. You could think of it as the brain of the whole operation, the thing that transforms all those separate little islands of GPU power into one single, intelligent, unified grid.
Hey, remember that no central visibility problem we talked about? Well, this is the solution. The EGS Continuum Map is what they call a single pane of glass. It's like a mission control dashboard for your entire network. For the very first time, an operator can look at one screen and see every single GPU they own, from the biggest data centers to the smallest edge locations, and see its real-time usage. Problem solved. So EGS really does three absolutely critical things. First, like we just saw, it gives you total visibility. You can see everything. Second, it creates a unified resource pool. It breaks down all those walls between different locations and treats all the GPUs like one giant resource. And finally, it enables intelligent placement, which is the smarts of the system that automatically figures out the best place for any AI job to run.
And this is that intelligent part in action. The EGS placement engine is basically a smart traffic controller, but for AI workloads. It looks at a new job coming in and asks questions. Is this an interactive chat that needs super low latency? Or is it a low-priority training job that can run overnight? And based on the answers, it automatically sends that job to the perfect spot in the network, whether that's the far edge, the near edge, or the core cloud that can do the job best for the lowest cost.
All right, so let's put this all together and look at the real bottom line impact. This is where you see the dramatic before and after transformation that unlocks all that hidden revenue we've been talking about.
Let's rewind for just a second to the before EGS world. Remember this? The user's job hits a full cluster. It gets blocked. The user is frustrated, and that potential revenue is just gone. Poof! Even though there's perfectly good hardware sitting idle just next door. But now, look at the with EGS picture. The whole system is one unified grid. When that same job comes in, the placement engine sees that cluster A is full and, in a split second, reroutes it to the idle capacity it sees somewhere else. The job runs immediately, the user is happy, and boom, the revenue is captured. It really is that simple.
And the final numbers here are, well, they're just staggering. You go from a world where you're using, on average, just 25% of your assets to a target of 90%. 90! You're squeezing almost every single drop of value out of a multi-billion-dollar investment that was mostly just collecting dust before.
Let me put it another way. That's a potential 3.6 times increase in GPU utilization. That is like turning $1 of investment into $3.60 of revenue-generating power, all without buying a single new piece of hardware. It's all done with software intelligence. This is a fundamental game changer for the economics of AI.
You know, when you step back, this whole story shows that as AI becomes the engine of, well, everything, just having the most raw computing power is only half the battle. The real winners and losers will be defined by who can manage that power most efficiently. Which leaves us with one final question to think about. Who is building the smartest grid?